वेलकम स्टूडेंट्स, कैसे हैं आप लोग? आई होप यू आर इन बेस्ट ऑफ स्पिरिट एंड हेल्थ. टुडे वी आर गोइंग टू कवर motion in two dimension, or we can also say that motion in a plane. Initially, we learned how to study motion in a straight line. So to have an understanding of motion in two dimension is motion in two dimension. Motion in two dimension. To have understanding, let's draw three coordinates. This is positive x, this is positive y, this is positive z. Okay, and this is the origin. The dotted line represent negative x, and this one is negative z, and then this one is negative y. Okay, so to understand motion in one dimension, motion will always occur in a plane. That is, there is a simultaneous motion in x direction as well as in y direction. When a particle traverses its paths, it will have both displacements in x direction and y direction also. So any plane can be chosen, be it xy. Maybe you can choose this xy plane, this xy plane. You can choose this xy plane, then zx plane, right? Then you can choose this yz plane. Okay, you can choose any plane, but the condition is that particle will at no point of time will leave this plane to come in this plane or come in this plane. It will continue to move in a plane, right? Suppose this is a board and the particle will continue to move on the board only. Okay, suppose a particle is kept on a table, right? A table is there. A table is there. The particle will continue to move in this table plane only. It will nowhere lift up to here. Okay, so what we understood, that motion in two dimension will always be accompanied by motion in one direction and simultaneously motion in the other direction. So now quickly come to another point wherein we can show you how we can have an understanding of motion in two dimension. Let's consider a coordinate. This is x. Here we are assuming that the particle is moving in positive x and positive y direction. Suppose particle traverses point A to B. Okay, wherein coordinates of particle changes from x, y to x plus delta x and y plus delta y. Okay, x, and this will be x plus delta x, and this will be y, and this will be y plus delta y. Then what will be this? This will be delta x by, this is delta x and this is delta y. Okay. So at any point of time, resultant vector can always be expressed as delta xi plus delta y j, where I and j are unit vectors in x and y directions respectively. Now we take derivative over time. Delta r by delta t is equals to delta x by delta t unit iota plus delta y by delta t j cap. Now taking limits where delta t is tending to 0. Now what will happen? This will become dr by dt is equals to dx by dt iota plus dy by dt j. Okay. Velocity, resultant velocity of the particle will be vxi plus vy j. Okay. So here we find that the resultant can be expressed as vector components of the motion in 2 dimensions, or velocity in the 2 dimensions, or acceleration in 2 dimensions. It can be. So we have a concept now that whenever there is a motion in a plane, we will first examine in 1 dimension, then on the 2nd dimension, and then we find resultant of the 2 dimensions, which will give the resultant displacement, velocity, acceleration of the particle. Now we are here all set to study projectile motion, which is an example of motion in 2 dimension or motion in a plane. Projectile motion. Take a coordinate. This is y, this is x. Now a particle is projected from origin at an angle of theta. Okay. So the particle traverses all along this path, coming back to this point. So velocity at different points of the trajectory will be like this. At any point, tangent at the trajectory will give the resultant velocity, and we can always have a component in x direction and component in y direction. Okay. At the highest point, the resultant velocity will be, suppose we throw a ball to the other fielder, it reaches the maximum height and then comes back to the ground. due to effect of gravitational force. So at this height, this will be the maximum height reached by the projectile, right? Similarly, at this point also we can always have velocity in x and y direction. Resultant velocity will be tangent to this. At the time of hit also we can find that trajectory that will resulted is this. We can always find x component in x direction and y direction. Okay. So applying motion, apply motion in x and y as one dimension independently. So if we consider the velocity, initial velocity, suppose u, then vx will be u cos theta, vy will be u sin theta, acceleration in x direction is 0 because acceleration due to gravity is acting in the negative y direction, so a component at right angle will always be 0. Acceleration in y direction is equals to, since it is in negative y, then in y direction the acceleration will be minus g. Okay. So 3 points we have to find out. First, time of flight. Time of flight means total time taken by the particle to reach from O altogether till B and then returning to the point C. Second is maximum height. Reached by the projectile, and third is range. This is range from O till this point where the particle is landing back to the ground. This is called range. So what is time of flight? How we can calculate? The initial position is this. The initial position is y. Initial position is O. Final position is C. Okay. So now applying the law of motion in a straight line in the vertical direction, what we can find out? For time of flight, we can see that the vertical displacement in y direction, the particle starts from the ground, reaches the ground, so there is a displacement in x direction, but in y direction there is no displacement. So for applying the laws of motion in one dimension, 0 display s is equals to ut. What is v? U is u sin theta minus half g t square. Okay. So taking t common, u sin theta minus gt by 2. Okay. So in other words, we can write t into u sine theta minus gt by 2. This equation is satisfied only at t is equals to 0, which is the initial point where the displacement is 0, and the other point where displacement is 0 is u sine theta minus gt by 2 is equals to 0. So gt by 2 is equals to u sine theta. Okay, so t is equals to 2u sine theta by g. This is the time of flight of the particle. Okay, right. So next what we have to calculate? Next we have to calculate the what is maximum height. For maximum height, what we need to take care of, that at the maximum height vertical velocity will be 0. Okay, so what we get, v 0 v square u square, since we have to find out u square is u square sine square theta minus 2 g and s. S is the maximum height. So 2gs is equals to u square sine square theta, right? So what we find, s, which is the maximum height, is equals to u square sine square theta by 2g. This is the second equation which we have deduced for maximum height. Okay. So we can also write h max, okay, is equals to u square sine square theta by 2g. Okay. Now the third point which we have to calculate is range. We have to calculate this range r. So what is the velocity? U cos theta and u sin theta. Okay, u cos theta to u sin theta. Now the horizontal velocity u cos theta will remain same. So since there is no acceleration in x direction, okay, so to calculate range, it is moving with uniform velocity. Range is equals to u cos theta into time of flight. This distance will be covered during the whole cos theta into 2. This 2u sine theta by g. This was the time, right? You can see that, verify that from that. 2u sine theta by g. Okay, this is the equation for time of flight. Okay, so now what we will do, we'll come back to the point. So this can be written as two u sine theta cos theta by G. Now 2 sine theta cos theta can be written as sine 2 theta this will be u square. Okay, so we can be written as u square sine 2 theta by G. So we got another equation of range is equals to u square sine 2 theta by G. Sometimes questions is asked that at what angle we should project the projectile so that we can get maximum range. For any particular velocity u is of projection, u is constant, G is constant. What we can vary? We can vary only theta. Okay, so sine theta has minimum value of 0 and sine theta minimum max. Maximum sine theta value is 1. That is when theta is equals to 90 degree. Okay, so 2 theta is equals to 90 degree. See, so theta will be 45 degree. So in order to get maximum range of a projectile, we have to project the particle at an angle of 45 degree from the horizontal to get maximum range. Okay, so I hope I have made clear all those things, and in upcoming examples I will be dealing with numerical problems to get an insight of all the applications of these formulas and how it can be correlated for case to case basis. Okay, thank you.